Leetcode 31, Next Permutation. Treat nums as one ordering of its values. The task is to jump to the very next ordering in dictionary order, in place. Here, swapping 2 and 3 after the pivot yields 1 3 2. Example 3 2 1 is already last in Lex order, so the next wrap is the smallest layout, 1 2 3. Plot the entries as heights. Walk indices from the right. While nums at I is greater than nums at I plus 1, the suffix is non-increasing, it is already the largest arrangement for that fixed prefix. The first index where nums I is less than nums I plus 1 is the pivot. Here value 2 at index 1 is that pivot, a change must happen there. We want the very next permutation, so we increase the pivot by the smallest possible step. Look only to the right of the pivot and pick the smallest entry that is still larger than 2. That successor is 4. Swap the pivot and the successor. The prefix is now 1 4, already larger than 1 2, but the tail is still a descending ridge. After the swap, the suffix is still strictly decreasing, so for this fixed prefix it is already the largest tail. Reverse that whole suffix to make it as small as possible. That yields 1 4 2 5 6 7, the next permutation. Step 1. Set I to the second to last index and move left while nums I is greater than or equal to nums I plus 1. The first time nums I is less than nums I plus 1, stop. That index is the pivot. Here the pivot value is 4 at index 3. The suffix to its right is non-increasing, so it is already as large as it can be for this prefix. Step 2. Scan J from the right for the first value strictly larger than the pivot. That is the smallest possible increase at the pivot position. Here 5 at index 6 is the successor to 4. Step 3. Swap the pivot and the successor. The sequence is now strictly larger at index I, but the suffix after I is still in descending order. Step 4. Reverse the entire suffix after I. That block was the largest possible tail for this prefix, reversing it yields the smallest tail and completes the next permutation. Edge case, if I walks past the left end, the whole array is one non-increasing peak, so there is no next permutation. Reverse the entire array to jump to the smallest ordering, wrapping around. Let n be the length of nums. Time is O of n, we walk backward to find the pivot index, walk backward again to find the successor to swap, then reverse a suffix. Each phase touches at most the whole array, and they add up to linear time. Extra space is O of 1, only a couple of indices and swaps inside the array. Pseudocode for next permutation, find pivot, find successor, swap, reverse the suffix. We walk the lines next. Store the length. Start I at the second to last index. Move I left while the pair is non-increasing. Decrement I each time the condition holds. If I fell off the left, the whole array is one peak. Reverse everything to get the smallest ordering. Stop, there is no next permutation beyond that. Otherwise set J at the last index. Move J left until nums J is greater than the pivot value. Decrement J while values are too small. Exchange pivot slot and successor slot. Reverse the suffix after I to minimize the tail.